A good rule of thumb where you have a word problem where it doesn't seem on the face of it that you have anywhere near enough information to actually solve it, that it is probably a Diophantine equation, and this is one of those cases. Okay, so let's have a quick look. Timmy's mother gave him exactly the right amount of money to go to the store and buy a certain number of apples, which each cost 7 cents, and a certain number of bananas, each costing 15 cents. On the way to the store, he found $4 on the pavement and was so excited he mixed up his purchase, buying the number of apples his mother wanted bananas and vice versa. When he arrived back home with a bag full of fruit containing more bananas than apples, he still had exactly the same amount of money as his mother had given him. How much money did his mother give him? Okay, so we've got to be a little bit careful here, and let's define our variables. So let's let x equal the number of apples that the mother wants Timmy to buy. And that also equals the number of bananas Timmy actually buys, because he buys the number of bananas his mother wanted apples and vice versa. And let's let y equal the number of bananas mother wants, and that also therefore equals the number of apples Timmy actually buys. So we can now get two equations. Let's call the amount of money that the mother gives Timmy m. So m equals, well, she gave him enough to buy x apples, which is 7 cents each, and she gave him enough to buy to buy y bananas, which each cost 15 cents. So that's how much money she gave him. Okay, now when he came home, he still had exactly the same amount of money as his mother had given him. So all of the money that he spent was that money that he found on the pavement, which was $4. So the amount that he spent, i.e. 400 cents, is equal to what he actually spent. Well, what he did was he bought X bananas, and each banana is 15 cents, and he bought Y apples. So that's what he actually spent. So what we need to do is we need to solve this Diophantine equation, and then once we've solved it, we can stick the values in there and we can get how much money she gave him. Okay, so let's have a look at this Diophantine equation. So 400 equals 15x, add 7y. Now, if you haven't seen videos previously on Gresti Academy dealing with how to solve Diophantine equations, please have a look at our playlist, Numbers and Number Theory. There are a few videos on that. So what we need to do is we first need to find the GCD of 7 and 15, and clearly that is 1, but let's go through the motions anyway. 15 equals 7 times 2, add 1, and that proves that the GCD is equal to 1, and therefore let's rewrite this as 1 equals 15 minus 7 times 2, or putting it in this way now, we have to compare it to this. We need to multiply everything by 400, so that gives us 400 equals 15 times 400 minus 7 times 800. Or, to make it exactly the same, 15 times 400, add 7 times minus 800 to make it directly comparable. Okay, so now we can compare this equation here with this equation here, and we can get a specific solution for x and y, which is that x equals 400 and y equals minus 800. All I'm doing is I'm comparing this and this with this and this here. So a general solution, and again, if this doesn't mean anything, please go and watch our videos where we've already described how to solve these two variable Diophantine equations. So a general solution will be x equals 400 plus 7p, and the 7 comes from there, and y is minus 800 minus 15p, and the minus 15 comes from there, for any p in the integers. So we now have our general solution for x and y. But what we need to do is plonk in a few values of p so that we can see which values of p produce x and y, which can actually answer this question. All right, now clearly x and y both have to be positive, so we're dealing with, let's have a little table here. So let's put y and x, probably better to put it the other way around, x and y. So let's have x and y here. Okay, now if we put in a value of p of minus 53, and then let's say minus 54, minus 55, minus 56, minus 57. Well, if we put in a value of p as minus 53 into this x here, we get that x equals 29, which is 400 take away 53 times 7. And y, if we put p equals, so here's p, sorry. If we put p equals minus 53 into this, we get y is minus 800, add 15 times 53, so y would be minus 5. Well, clearly then, minus 53 does not work as a value, because that would mean we would have a negative number of bananas or apples. Okay, so let's have a look at minus 54. If we plonk minus 54 into here, we would have x is 22 and y is 10. If we put minus 55 into these two equations, we would have x is 15, y is 25, and here we go, you can see there's a pattern emerging here, 8, 1, 40 and 55. Okay, now let's have a look. So these are basically the values, and these are the values that are possible, but there's one thing in the question which only means one of these is viable, which is that he had more bananas than apples in his bag when he came home. Now the number of bananas that Timmy actually bought is x. So we know that x must be greater than y. And the only value of x here, for which x is greater than y, and they are both positive, is x equals 22 and y equals 10. There are no other values. It's clear that this is going to become more and more negative and this is becoming more and more positive. So therefore we know that the answer is x equals 22 and y equals 10. That is the only possible solution. Now all we need to do is go back to our equation here. M equals 7x add 15y. So the amount of money she gave him is 7x add 15y, which equals 7 times 22 add 15 times 10, which equals 154 add 150, which equals $3.04. So we know that Timmy's mum gave him $3.04 to go to the shop. And there we go. Hope you enjoyed this. If it was helpful, please subscribe to the Gresti Academy YouTube channel. Thank you.